Howdy guys, it's Jesse here from Elevate with another chemistry video. Now this is the last one for enthalpy, and again what we're looking at here is not just answering the question, but looking at developing that deep understanding. Now the question we're going to tackle right now to try and work on this is from the 2013 HSC exam. And of course, it should be pretty obvious, but I want you to have a crack at question 27. So pause the video now before we do anything else, have a go at that question, and I'll see you on the other side. Fantastic. Hopefully you didn't find it too challenging. Now, this might not actually be exactly covered in some of your courses, depending on your curriculum, but again, it's important to understand these concepts which apply to all curriculums throughout Australia. Now what we've got here is a pretty interesting looking graph. Now you guys might not have actually come across this sort of graph before, but all we've got here is a temperature and a time. Pretty straightforward. And that's all we need to really focus on. And we've got these three really distinct points here, and you know what? They're probably pretty important. So I'm going to skip all this stuff up the top, but focus on the question instead. Using the information shown on the graph, calculate the specific heat capacity of the oily liquid. So that's the bit we need to really focus on, specific heat capacity. And hopefully you know the units of that bad boy. And we're going to be looking at dimensional analysis once again. So, specific heat capacity, sometimes written as C, sometimes written as CP. That's how I prefer to write it. And you know what? Let's say I don't know what the equation is, but I do know that the units are in joules per kilogram per Kelvin. You know what? We can probably use that to our advantage somehow. So that means we're going to need an energy, a mass, and also some sort of change in temperature. Those are the things that we're going to be really looking for here. So, let's get into it, guys. Sorry about the pause, going to cut. Alright guys, so let's get into it. I'm going to work on the most straightforward thing here, and that's the mass. So the mass, handily enough, we've been given right here, a 0.259 gram sample of ethanol. But wait, we're actually talking about the oily liquid over here. No, crap. Did not say that well. Cut. Sorry, whoever's editing this. So the first thing we're going to start off with is finding this mass. Now notice, we're actually looking at the specific heat capacity of the oily liquid. So that means, I'll just write it down over here, the mass that we're going to be using is, of course, 120 grams. But we need it in kilograms, because that's our units. So it's 0.12 kilograms. Now what's our change in temperature? Well, that might be a little bit hard to guess if we're actually looking at this graph overall. Well, how are we going to work out what the change in temperature is? Now we know the specific heat capacity is about how well something takes in energy and converts that into a temperature change. So that's all about when something is being heated. So that's the bit that we're going to look at here, from this part of the graph to this part of the graph. In which case the delta T is simply 30 degrees C. And in case you didn't know, that's the exact same as 30 Kelvin, which is what this unit is here, of course. But what's our energy? Well, thankfully enough, we haven't really done much work so far, and this question is worth 4 marks, so maybe that's something we're going to have to figure out. So let's have a look at how we might potentially find energy. Now, energy is usually equal to the number of moles times the heat of combustion, and that should be pretty much enough to sort us. Now, if you're not familiar with some of these variables, don't stress. All the working out's going to pop out to something you should be pretty familiar with. So let's work out the moles. And the moles in this case isn't of this oily liquid, because how are we going to work that out anyway? But the moles is actually this 0.259 gram sample of ethanol. So let's work that out right now. So moles of ethanol, which of course is C2H5OH, is equal to the mass divided by the molar mass So that's our 0.259. Divide by our molar mass, which for ethanol, depending on how accurate you need to go, is 46.068. Always use the accuracy that's given in your data book, guys. Key lesson there. And that's going to pop out to 5.6 by 10 to the minus 3 moles. So, let's work out that energy. Now, thankfully enough, we actually have this heat of combustion right here. So we don't need to do anything to work that out. Instead, all we have to do is actually times those values together. So all we're simply going to do is energy is equal to 5.6 by 10 to the minus 3 times 1,367, which gives us 7.685 kilojoules. Fantastic. Now, unfortunately, we can't right now substitute this energy back into here, and the reason why, again, is this is in joules. We need all the units to be the same. So this is equal to 7.685 by 10 to the 3 joules. Converting kilojoules into joules, all you have to do is multiply by 1,000. So that's how many joules we've got, and now we can simply plug in those numbers. So we've got Cp equals joules per kilogram. Cut. Start up again. So we've got Cp equals joules per kilogram per Kelvin, and that's of course changing Kelvin. And now we can put all these values in as long as they are the right units, which of course they are now that we've dealt with them. So we're going to put in 7.685 by 10 to the 3 divided by 0.12 times 30, and you should get an answer of 2,134.84 joules per kilogram per Kelvin. So what were some of our takeaways that we really wanted to get from this question? The first one is to just get used to these sort of questions. How do I actually deal with CP values? How do I deal with these specific heat capacities? And how do I obtain that from these sorts of questions? Additionally, it's important to be able to understand how this graph works, and what the important bit was during this section. And the reason why was because this is where the energy was absorbed into this oily liquid, and that means that's where the energy was released from the ethanol. The last thing I really want you to take away is this principle of dimensional analysis. So the fact that my specific heat capacity is literally equal to my joules divided by my kilograms times by my Kelvin, that's as simple as it gets, guys. Then you can just plug in the numbers and away you go. So make sure you try and understand this principle, and hopefully you can now understand these graphs from now on. But the real bit I want you to focus on is that dimensional analysis. Thanks for watching, guys. I'll catch you in the next episode.